Thank you all for standing by, and welcome to today's webinar, Dynamic Certificate Management on F5 Big IP using HashiCorp Vault. My name is Karen Hui, Senior Partner Marketing Manager at HashiCorp, and I'll be helping to facilitate today's webinar. Please feel free to type your questions during the webinar. This webinar is recorded, and the recording will be made available after post-processing, usually within 2 days. Our speakers today are Alex Khan, Senior Partner Alliances Manager, HashiCorp, and Sanjay Chode, Solutions Architect, F5. They'll be talking about improving security posture with short-lived dynamic certificates for your applications, using F5 AS3 and HashiCorp Vault to configure a cloud-independent automated certificate management solution to issue short-lived certificates for applications. Please feel free to reach out directly to the speakers for any follow-up questions. And now let's get started. Over to you, Alex.
Right. Well, good morning, good afternoon. Thank you very much for joining us. So I'll get started. So as Karen mentioned, my name is Alex Khan. I'm a Senior Partner Alliance Manager at HashiCorp, and Sanjay is from F5 has kindly agreed to join us today. So let's get into it and get into the agenda. So today, what we're going to talk about are certificates, and we'll give you an overview of the what, why, and how. And then we'll dive into both Vault and Big IP automation toolchains as a solution. And then how do we use these together to issue dynamic certificates? We will then go into a demo where Sanjay will do a deep dive into seeing this live, as well as talk around the benefits. And then we'll have time at the end for a question and answer session. So certificates, the what, the why, and the how. So what are certificates? They are formally known as X509 certificates, and they're typically used for authentication and encryption. So certificates are issued by trusted certificate authorities, and they issue what is known as a root certificate. And so a root certificate is the master or the ultimate certificate that is issued for an organization. The way that it's generated is you do what is called a CSR, certificate signing request, and you reach out, you send a bunch of information to these certificate authorities, and they will return to you this root certificate. This is the most crucial piece in terms of securing your sites or infrastructure around it, and it is closely guarded. So root certificates are typically stored in a hardware security module or somewhere offline and are particularly and are very, very trusted. So from root certificates, you're now able to create child certificates, and these fall into two forms. One is called an intermediate certificate, and intermediate certificates are able to actually have other children certificates, or they can be a final one. And then you have what is known as a leaf certificate. And a leaf certificate is a certificate that is not able to have children. So what these form are the chain of trust. Now, you have certificate authorities that publicly issue these. So these are companies like VeriSign or DigiTrust or Let's Encrypt. And they're the ones who will actually provide these root certificates for companies. So kind of a really high level of the what. So why do you use it? Well, it's all around security. So it's for use of encrypting web browsing, encrypting emails, code signing, document signing, client authentication, and ultimately it's about establishing trust between entities. So there's a huge thing in the world of zero trust where you no longer have a defined security perimeter. So you need to be able to establish trust between entities, and this is really where verification comes from, and this is primarily used for certificates. So they provide public keys that are used to verify that a server is who it say it is or it's representing X number of company. So how do we do this? Well, servers or certificates are typically installed on servers. In the case of TLS, this is where a certificate is installed on a single server. Your client, which is usually your web browser, will connect to it. You'll get a public key, validate who it is. In the terms of mutual TLS, which is something that's extremely important in this world of applications and microservices where you have communication happening between two machines, and establishing that trust is crucial. You actually have both machines exchange certificates to be able to verify their authenticity and who they are. Now, in the world of issuing certificates, this has typically been a manual process. So you go and actually install a certificate. You would go and manually do the CSR. There are ways to build in automation, but still today, for a large number of organizations, this is a process to both get them issued and distribute them. And one thing to note is root CAs, actually in all certificates, are kind of known as long-lived certificates, especially when they have long expiration dates. So all certificates will eventually expire. Root CAs can last anywhere from 10 to 30 years. I've seen intermediate certificates lasting anywhere from 5 to 15 years, and then leaf certificates lasting for a year or two. And this has some extreme risks associated with it. And the one we see most often is around certificates expiring. And so there's a couple of real world examples where we've had some massive service outages in very large, well-known cloud providers where actually, a collaboration tool went offline, and all this was due to an expired certificate. You've had large Global 100 companies have issues because they've had expired certificates. And these are not the things that companies think about as first off is why my website is no longer working. And the experience for a user is quite jarring. So you'll log into a website, you'll either get this message you see on the screen, the website is unavailable, or you'll get something even more scary saying you no longer trust this website. Ultimately, this will cause downtime, reputational damage to an organization, or at least loss of revenue. The other big risk with long-lived certificates is if the private key, so the key that was generated as part of this, that ensures that authenticity certificate is compromised. And this was really shown in a flaw that was codenamed Heartbleed that happened in 2014. And this was a flaw in the OpenSSL crypto library. So this library is used to generate most of the certificates in the world and being signed by other root CAs. And it was discovered and fixed in 2014. And basically allowed attackers to figure out the secret keys for these certificates. So they were able to now eavesdrop on communication, steal data directly from sites, as well as impersonate other sites and users in order to retrieve more data and also steal money. According to Malwarebytes, back in 2019, they wrote a blog. So this is 5 years after Heartbleed is. They were still discovering a large number of systems still using these compromised certificates. What are some other challenges, and really, what are you doing to help enable your business to move faster? So certificates are, especially with these long-lived certificates, you have to keep track, like have you revoked them? How do they expire? And you maintain what is called a certificate revocation list, so the CRL. And this has become a very difficult problem to solve, especially in this world where you're issuing a lot more certificates than you used to. So 10 years ago, maybe you issued 15, 20. Today's modern infrastructure, especially with microservices, you're issuing thousands of certificates, and maintaining a CRL is actually really not feasible. And today is not a problem that's actually been solved by any one company. Another particular challenge with long-lived certificates are the people who install these certificates will leave. So then you no longer know where they've installed it, when they didn't, when these certificates will expire, did they take the private key with them? So you potentially have a risk. And if these certificates are compromised, then they live for a long time and leave that vulnerability up for you until you actually identify that breach. I mentioned that we have microservices. With the explosion of microservices, all these services need certificates in order to communicate securely with each other. And now you're starting to get into this issue of, I have 1,000 certificates out there, I have to try to maintain a CRL. It's just not really possible for organizations to be able to do this. There's a little bit of an edge case as well with certificates where you have potential performance challenges with them. So when you go and actually do a check against a CRL, that's one way you can validate if the certificate is still there. The other way is using what is called an online certificate status protocol, so OCSP, and this is really another validation check. But either way, it's still a bump when you're going to validate and navigating to websites. And so it's really trying to figure out how an organization takes, I need to be secure, so I have to have a certificate, I need to be able to issue this for in there, and how do I actually enable my internal customers to use this quickly, to adapt to market changing conditions, to help our developers change, but still maintain that really large balance between security and agility. And so we come up with this idea of short-lived certificates. And so what are short-lived certificates? Well, they're normal leaf certificates with a very small time to live. So this could be minutes, hours, days, weeks, maybe months. But the idea is that they reduce your exposure if something happens. And the nice thing is they're better performant because you don't need to go to a CRL and OCSP because it has such a short expiry time. Your risk of if a certificate is compromised is massively reduced because if the private key or the private encryption key is discovered or stolen, well, they have a very short amount of time to try to do something with it because otherwise the certificate expires. They're great for mutual TLS and microservices because, again, as these services tend to be quite ephemeral and they come up and come down, you want to be able to reissue new certificates each time rather than reusing this, again, reducing your exposure if something bad were potentially to happen. And so we talked about certificates being, a very manual process. So now it becomes into is like, how do I operationalize this? Like, you're saying best practices to use short-lived certificates, but now I need to be able to distribute to a lot of different systems. And so the key is going to be automation, automation, automation. So really how you're able to do this is have machines issue these certificates, manage the life cycle of them. So you're really reducing your risk of expiry. You're increasing your ability to scale, especially as you build up more and more of these microservices. And you're reducing the operational overhead. So no longer are individuals having to keep track and update the CRL list. You're actually having the system take care of it. And so, we at HashiCorp have actually an application that can help with this automation. And so this is where we'll do a quick dive into HashiCorp Vault. So for those that haven't heard of it, HashiCorp Vault is a tool for securely accessed secrets. And the secret for us is anything that you want to control access to. So it could be an API key, could be a password, or it could be a certificate. And Vault provides a unified interface to any of these secrets while providing an access control, so making sure the right people have the right access to the right secret, as well as an audit log so you can actually go through and verify who's accessed all these secrets. One of the key components of the secret management use case is the ability to use what is known as dynamic secrets. So Vault will actually generate secrets on demand for certain systems. So this could be databases, could be infrastructure. So for example, AWS IAM roles, for example, or PKI certificates, which stands for public key certificates, which is how X509s. And so after creating these certificates, Vault actually issues them with a lease associated with it. So after a certain amount of time, those secrets will be invalidated and revoked. Now, there are a couple types of secrets engines within Vault. So it has a very modular system. One, which we've mentioned before, the database secrets engine. We have the ephemeral infrastructure secrets engine. So this is for AWS, GCP, or Azure, as well as the PKI secrets engine, which we'll touch upon shortly. A couple other use cases for Vault. We have data encryption. So this is really enabling Vault to encrypt or decrypt data without actually storing it. So this allows security teams to define encryption parameters and for developers to store data encrypted without having to actually invent their own encryption methods. So this is best practice of security by default rather than actually someone having to reinvent the wheel. And finally, we have what is known as the advanced data protection, which is really allowing Vault to act as an external key management server. So if you have full disk encryption or transparent data encryption, you need keys, so Vault can serve it up. We have other use cases. For example, you need to tokenize data, or perhaps you need to actually encrypt data, but in a specific format. So all of this is solvable by Vault. Now, ultimately, Vault is API driven. So everything that you're using in Vault, whether it's the UI or the CLI, is actually done via API. And this makes it extremely automatable. So when we talked about being able to issue all of these lease certificates through automation, Vault is able to do this because of the fact that it is an API-driven machine. So let me jump into PKI secrets. So what is a PKI secrets engine? Well, it's enabled to issue and distribute short-lived TLS certificates on demand. So this is primary use case is being able to do this. It does support the CRL list if you need to, and if your organization demands it. However, again, we do recommend that you use short time to live on the certificates, as it's a better pattern. And it's really flexible in the sense that you're able to integrate it into all of your workflows, again, because it's API driven. Now, there's a couple things that we want to talk about. So Vault can actually act as a root CA. So it generates what is known as a self-signed CA, where you would use this for internal use cases where you have machines within your infrastructure that explicitly know that they can trust each other because of the CA, and Vault is able to distribute and send out certificates based on that. Also, Vault can talk to external certificate authorities and basically create what is known as the intermediate certificate, get it signed by this external CA, and then be able to issue the lead certificates in there. And so again, this is all about how do you be able to operationalize and really increase that agility, again, with keeping the security in mind. And there's one other aspect to mention is because we talked about this modular design of Vault, Vault is able to actually use external plugins. If you have services from companies like Entrust, Benify, Global Signs, Secticode, et cetera, you're actually able to get certificates issued by those companies via Vault through the exact same mechanisms that you use today if you're using Vault's internal system. So it becomes very, very composable. And with that, I'm going to hand it over to Sanjay to talk about the F5 automation lifecycle.
Thank you, Alex. Thanks for the explanation. So today we'll be looking at how we can integrate Vault into F5 and how we can rotate the certificate using this, right? For that, the important thing is F5 automation toolchain, which helps customers to deploy application services on big IP easily, as well as faster and using simple declarative API sets. So developer can seamlessly integrate F5 into their CI/CD chain, right? And also into their orchestration system, as well as any third-party ecosystem. So if you look at F5 automation lifecycle, we have like different lifecycle there, starting with bootstrapping. Like for bootstrapping, you can use F5 big IP image generator tool to generate the images. We support all public as well as private data center, most of them. And then for onboarding, you can use declarative onboarding extension, which is like, let's say if you are onboarding a big IP, you need things like VLAN, self-IP, NTP, DNS, those kind of features we need to enable. So you can use this declarative onboard extension tool. You can also customize the configuration using Cloud Init, right? Using user data at the launch time. And then let's say if you're deploying an application, new application, for that application, you need a lot of things. Like, for example, you need server load balancing. So you need to specify, you need to configure your big IP with your virtual server, your pool members, your nodes, your profiles, your iRules, and so on. So all that thing, which is which you can say like a day one activity, you can do using application service 3 extension, right? And you can basically have that AS3 JSON payload and deploy that payload with a single API, declarative API on big IP. So that way you don't need to have imperative API calls. So that way the number of calls, API calls you are making are reduced. Right. You can also abstract AS3 using FAST, like F5 app services template, FAST, which can expose only few parameters instead of populating all the components of the JSON payload. You can expose few of them, and then that way you can abstract it, and it's like much easier to deploy and things like that. So for monitoring, you can use telemetry streaming extension. We support most of the popular logging analytics tools, like, for example, Splunk. We support Datadogs, Sumo Logic, and so on. And if you have a very tighter integration you want to make, you can always use the F5 SDK to do that. So now in this solution, what we are doing is actually using Terraform to deploy the instances like your big IP instance, your Vault server, your backend application. Also, what I'm doing is actually pushing the configuration, the templates which are required, AS3 templates and all, through the Terraform itself, right? And then what we're going to do is use Vault agent. So what Vault agent will do is it will talk to the Vault server to get itself authenticated using your role ID and secret ID, and once it gets authenticated, it will get a token. With that token, it will use to pull all the secrets certificates out of Vault, and then it will create a AS3 template dynamically through templating, and it will deploy that template into the big IP. So that is the thing, right? So let's look at the demo. So this is the process actually. What we're going to do is create big IP, install and configure the Vault binary as well, start up the Vault server, then enable PKI secrets, generate CAs, and then finally configure app role policy in Vault for machine-to-machine communication. And then we'll execute a Vault agent so that it creates the certificates dynamically, and those certificates it will push to big IP. So those certificates will be like, depending upon your TTL, time to leave, it can go from few seconds to days or months. So accordingly, you configure your policy and or your PKI, and then you can run Vault agent to generate those certificates. So let's look at the demo. So I'm going to share demo here. Yeah, let's. So this is what I have my Terraform scripts already deployed. So what I've done is that just before my webinar, I did a Terraform apply, and we got all this thing installed in terms of your big IP, your Vault server, which is Ubuntu based, and then your Vault. And so let's go and look at some of the configuration in terms of AS3, right? So this is the template which I'm using. This is the AS3 template, which is used to configure your big IP. So the important thing here is actually we are creating a tenant here for a particular application, assigning the virtual IP for that application, also defining pool members for that application. And the thing here to look at is the web cert. So this is the certificate class, and all this certificate, the private key, and the chain CA, all these are actually templatized. That means what it will do is, once this template is rendered, it will replace these values. It will substitute the values with the actual certificate after talking to the Vault server. Then we have the app policy here. We are using role method as app role. So we need a policy for that. Then let's talk about the agent config here. So the agent config is, we are pointing to the agent here, defining the app role. So getting the role ID and secret ID from that. Once we get the token, we store the token on app role token. And then this is very interesting part, actually, the template. So here what we are doing is that you can see, like, we are using certs.tmpl file, and the destination is JSON. So that means this template will be rendered. Once it is rendered, it will generate the cert.json here. And here I have commented this out because initially I just wanted to create a AS3 template, because since this is a greenfield deployment, nothing is there on the big IP currently. There is no configuration on big IP. So I need to generate the AS3 first, deploy the application which matches to my backend application as well. And once I do that, then I run agent again, so that my updated certificates are updated frequently after every 160 seconds. So we'll go through all those details. So this is the cert part, cert TMPL, which is here actually it's making, this is the replacement part, the templatizing part. And so let's look at the Vault server now. Let's log in into the Vault server. So I'm going to log in into Vault server now and configure all these parameters. So we are on the Vault server. If you go to TMP file here, you can see that all the templates I have already pushed through Terraform. For example, I have the TMPL file, then I have the agent file already there. I have the install RPM for the AS3 part, and update.sh scripts which are required to make an API call to the big IP. All that thing is available here. So let's look at, let's configure Vault now. So what I'm going to do is now configure Vault server. So these are some of the parameters which are required for the Vault server, right? So now if you look at Vault status, you should see that my Vault is, I'm able to access Vault. Then let's look at Vault here. Okay, so now let's configure some of the remaining parameters. So I'm configuring the PKI here. So in the PKI, I'm configuring the allowed domain as demo f5.com. The TTL value is 160 seconds. So that means after 160 seconds, the certificate will get expired. So what agent will do is actually will contact Vault, get the new certificate, and deploy that certificate onto Big IP. So I'm configuring my app role here, enabling the app role. I'm also associating the policy, which we talked about, the Vault policy. And also I'm defining, associating the policy with the web cert app role. And then finally, what we're going to do is actually read the role ID and read the secret ID. Why do we need this is because we need to authenticate to Vault to get the token. Okay, so now let's do that. Let's run Vault because this will generate the AS3 JSON, right? So now if you look at here, we already generated the AS3. You can go and look at that. So we have the AS3 generated with all the parameters required. We also got the demo cert. We got the certificate. We got the private key. We got the chain CA as well. What we're going to do is now run the script so that it deploys the RPM, which is the Node.js package for AS3 on Big IP, and it will also configure the. It will also push the AS3 onto Big IP so that all the tenant, the virtual server, the pool members, and the node are configured. So let's look at the detail here. So we have the Vault server here. Like I said, we have the PKI intermediate already. This is the web row we have, and this is the certificate which we pushed, right? So sorry, the PKI rule TTL value which we pushed. Like in this case, it is 160 seconds.
Sanjay, sorry to interrupt. You've stopped sharing your screen.
Oh, sorry. So let me.
No problem.
Are you able to see?
Not yet. Now it is. There you go.
Okay. So I got this TTL now 160 seconds, and this is my Big IP. So let's log into Big IP and see what's going on there. So I need to grab the password for that. I'm just grabbing the password for Big IP. Okay, so let's enter that. So now I'm into the Big IP. You can see like, let's go to the virtual server. And if I go to the tenant, the demo F5 tenant, which we created AS3 and applied this tenant here. So I have the tenant live. Let's look at the certificates now. So if I go to the certificates, you can see that my certificate is already expired because the TTL is only 160 seconds. So already 2.5 minutes have passed. The certificate is expired. Now how do you solve this problem, right? So that's where what we do is go to the agent file, and this agent you can run on any VM, and you can run as a cron job. And once you start running this agent, it's gonna look at the expiry time, and as the certificate is getting expired, it will check with the old server, get the new certificate, and run the update script so that it makes an API call to the big IP and refresh the certificate. So I'm gonna uncomment this because that's what we want, and save it, and then run the agent again. You can see that now I'm updating the certificate every 160 seconds. So the certificate is updated. Now this thing will keep on going, and as long as the certificate is getting expired, it's gonna retrieve the replenish the new certificate, and this is going to go forever. So now you can see that the expired certificate error has gone now, and my certificate, if I dig more deep on this one, you can see that my certificate is going to, this certificate will expire at 10:30, 35:35. So it's all another couple of 2 minutes, almost 2 minutes, right? And then I can also go and see, okay, let's look at my backend application, how it is doing, right? So let's log into that. My port is, I'm running nginx at the backend. This error it is showing because of the private certs. So you can see that my nginx response is back in. I can also look at the certificate. I can see that this certificate will expire soon, maybe another couple of, another minute maybe. And then you can go back here and see that things are moving fine. So you can fine tune your certificate. You can adjust your TTL accordingly, whatever you want to configure. This for the demo purpose, I just put 160 seconds. You can make it like a couple of days or months that way, right? So let's go back to the slides here. So you can see that the benefits are extreme. Actually, you can see like you can use AS3, which is very robust, to update your certificate, and it is using declarative APIs. That means the number of calls required to make to configure a feature is less, because we are not using imperative. Imperative has more number of calls. This is, since it's declarative, it's much easier, and it won't affect your scaling requirements. Then it is, the solution itself is cloud agnostic. That means you can deploy it in on-prem, or you can deploy it in public cloud. As Alex mentioned, short-lived certificates are much more higher security, provides higher security. So you can have dynamically created certificate, which are much short-lived, and that can provide you much higher security, right? Also, you don't need to monitor the solution as such, because once you are running the script, once you're running the agent will take care of updating the expired certificate. So once it is running, you don't need to have those operational challenges which you have when you are managing different SSL certificates. And then you can always configure the TTL. Like I said, like it depends upon what is your requirement. You can configure it for months or hours or whatever it may be. So, and then you have all those useful resources here. You can use, so let's say if you want to try something out, you can always git clone on this repo and create the scenario. So everything is automated already. You can use Terraform to deploy all the configuration, all the instances as well. So
So we'll go ahead and move to the Q&A. Session was around the issuance of licenses for Venafi in terms of number of certificates managed, and would this save or shift away from that? And I can't speak on behalf of the way that the Venafi's licensing model works, but I don't believe so, because effectively you could actually use a Venafi plugin, which then would be able to issue those certificates from their service via the automated process within Vault. Now, and you would still get the benefits of using a Venafi where you're actually having, essential more of the governance, those sorts of aspects. So it's not something that we would say use Vault PK engine over one of the other providers, just because there's benefits to using both, and it's a nice central way to be able to manage them. There was also a question, and this is for Sanjay, around when the certificates are being rotated, are there any service impacts during this? So, when you're issuing these new certificates.
Yeah, so typically there are no outages as such, because once you have all the parameters defined in the script, so basically it's gonna run the exact thing, right? Like if you can see here, actually, it will make the API calls. It will get, it will populate the AS3 using the template, and it's pretty much there is no downtime as such. But if you run into some problem, actually there are logs which you can enable on BigIP, and those logs you can send to analytics solution and see what is going on in terms of the API calls. Are you getting any errors? And also when you are running Vault agent itself, you can see that are you getting those 200 the OK messages or not, right? So if you are making an API call, if you are not getting 200 OK, that means there is something wrong in terms of making API calls, or you are not reaching the BigIP and so on.
Got it. Thank you. There's another question in here around how does the script scale for multiple SSL certs on the same BigIP?
Yeah, you can have multiple templates for, let's say, if you are deploying like 2 applications, or let's say 100 applications, you can have those many files, templates pushed onto the Vault agent, and accordingly you will have, for those different applications, you will have different domain names, obviously, or app name accordingly, right? So for each AS3, you can have for each application you can have a different tenant created, and those tenant can have different applications, different certs, as well as private key generated automatically through Vault. So when you look at when you are configuring PKI, you can define the allowed domains. So the allowed domains will correspond to what application you're pushing, and accordingly you can have different PKI, basically different domains defined in the allowed domains, and those will be unique certificates for each of the applications. And when you're scaling, actually you can use the agent file, and you can define those parameters in the agent file at the template option, wherein you define the source, you define the destination, and then you define the command, what you want to do in terms of making API calls. Hope I answered the question.
Excellent. So there's an additional question. Does this work with, does this have any integration with BigIQ?
Currently, we didn't look at BigIQ yet, but it should have. Currently, it's not. We didn't test this with BigIQ though, so we need to think about it.
It looks like there's some other questions as well too. Can we use third-party certificate authorities in this solution, and how easy is it to integrate? I think that's for you, Sanjay.
So different third-party CA?
Yes.
Okay, yeah. So Vault supports different CAs, right? Whether it is your Entrust or your Let's Encrypt. So what gonna happen is actually Vault. So let's say if you want new certificate, the agent will request to the Vault. Vault will go and talk to CA and get the certificate, and those certificate will be delivered back to the agent. And the agent will use that certificate to populate your big IP. So there will be small change in terms of how you build this solution, because you have Vault talking to CA directly, and then you have your big IP, right? So you have big IP, yeah. So I was just saying, like, you will have your big IP, then your Vault, and then your CA. So
yeah, we have one more question came in from Arun. Does this automation give opportunity to increase encryption bits during renewal? For example, from 1024 bits to 2048 bits, or from 2048 to 4096. I hope that made sense.
So that will it will depend on the Vault, right?
Yeah, and Arun, I'll have to get back to you on that, because that one I'm not 100% sure if, and I'm trying to remember the way that Vault generates it, because you can set the encryption length as part of configuring the secrets engines. But I don't know if you would have to potentially create a secondary secrets engine that could still have it signed by the root CA, for example, if you're going to create, because remember, you can have multiple PKI secrets engines. In that case, you might be able to do it. But let me validate this and double check. So I will give you the world's most wishy-washy answer, is I think so. But let me validate it. And in terms of the zero trust, let me verify, and I'll get back to you on that.
Thanks, Alex. And Arun actually had another question. Is this limited to single domain certificates, or can be applied to all certificate types?
Sorry to interrupt. Yeah, so it can be. You can. So the way that the PKI engine is configured is you can actually create it for wildcard or single domain. There are some configurabilities when you're specifying some of the details around the certificate issuance.
Thanks, Alex. And where can I install the Vault agent? Do we need a dedicated server? I think that might be for you, Sanjay.
Yeah, I can take that and what we've seen in live. So Vault agent is typically the classic deployment for HashiCorp Vault is you have a centralized Vault server, or you can actually deploy it on HashiCorp Cloud Platform as a managed service for HashiCorp. And so the agent actually will run on either a server next to your application, or actually potentially even on the same server as the application. And what the agent is really able to do is actually cache effectively secrets, so you don't have to do a whole round trip back to the centralized Vault server. And it does it in a very secure and authenticated way between it. And so typically it's deployed next to an application.
Great, thanks, Alex. And can we use a solution in brownfield deployments?
Yes, you can use that solution in the brownfield deployment. You just need to make sure that you match whatever the configuration you have on your big IP to the AS3 which you are deploying. So what you do is actually just run the agent file with the command option. And make sure that you have all the other parameters in terms of your virtual server, nodes, everything configured accordingly. And only the certificate part will be changing in terms of, getting the new certs from Vault and then pushing it to the big IP. Yes, so you can do that.
Thanks, Sanjay. I think we only have another few questions, and we'll just run through these. Why is AS3 better than using imperative APIs?
Yeah, AS3 is because when we use AS3, actually you have only one declarative API. Basically, you have a declarative payload or your declarative JSON blob, but when you are pushing that blob to the big IP, you have to only refer to one API instead of multiple APIs. So for example, you can club together multiple features uh, like nodes, virtual server, iRule, profiles, everything in a single JSON, and then push that JSON onto big IP using only a single API. So that means number of calls which are required to make to the big IP is less. The imperative way of doing is actually it has to, for each feature you have a single API. In that case, if you are configuring the feature, you have to do multiple calls. Multiple features, if you want to configure, you have to do multiple calls. So that way it's not that efficient as AS3.
Thanks, Sanjay. Arun has a few other questions, and we'll just maybe get through those two that we have there, and we'll have to finish up for the webinar. But if the root or intermediate certificate requires renewal, will this automation apply on all VIP profiles?
Can you repeat, Karen, the question?
Sorry, if the root or intermediate certificate requires renewal, will this automation apply on all VIP profiles?
Yes, actually those root certificate, so currently the CA we are using as Vault. So root certificate you're getting from the CA itself. And the intermediate CA is also basically, we use intermediate CA wherein Vault supports that as well. So the CSR as well as the intermediate CA is supported by Vault feature itself. And so we are using that, and then you can use those, you can generate multiple certificates for different VIPs as well. So you can do that on common partition, or you can also do it on the private partition or multiple partition. I'm not sure whether I answered the question, but yeah.
Thanks, Sanjay. And the final question, can we push this automation through big IQ rather than reaching individual F5?
Currently, that feature is not there, but we can definitely use the APIs and shell script to achieve that. But yes, through Terraform, you cannot do that currently because we still need to work on some of the resources which are required on big IQ. But you can definitely use big IQ has a lot of like open APIs which you can use to achieve this.
Thank you so much, Sanjay. We had a lot of questions there. Thank you to the audience and thank you, Alex and Sanjay, for a great webinar. I hope everyone enjoyed today's webinar and has a better understanding of dynamic certificate management on F5 Big IP using HashiCorp Vault. And finally, as mentioned at the beginning, this webinar was recorded and we'll make the recording available after processing. I'll send an email to everyone who registered with the recording link. Have a great day, everyone. Goodbye.
Thank you.